When you look up at dawn or dusk, you can usually spot Venus. It's the third brightest object in our sky, floating there as a pristine, glowing point of light against the void. But that bright glare is deceptive. Light reflects off an unbroken wall of clouds, soaked in sulfuric acid, hiding an atmosphere made of carbon dioxide. Beneath that layer, the air is so dense it crushes down with 90 times the weight of Earth's atmosphere. For centuries, astronomers stared at this blank sphere. Because visible light cannot penetrate that toxic fog, the surface remained entirely hidden. This led to assumptions that the planet was a harmless twin of Earth, perhaps a tropical paradise, simply because of its similar size and location. To see what was actually trapped beneath those clouds, scientists had to throw heavily shielded machines directly into the heat and listen to them die. In the 1970s and 80s, the Soviet Venera missions attempted the impossible. Engineers built these landers with reinforced titanium hulls and thick thermal shielding, knowing the environment would destroy any standard probe within minutes. Upon landing, a probe faces a surface temperature of 465 degrees Celsius. The atmospheric pressure at the base of this furnace is the equivalent of standing nearly a kilometer deep under Earth's ocean. In 1975, Venera 9 survived for about 50 minutes. It transmitted a single grainy frame, warped by the heat and pressure. It showed a desolate landscape of flat, jagged rocks, proving the surface was a solid, scorched wasteland. Later missions sent back color data, revealing an environment where the thick atmosphere blocks out most sunlight. This creates a heavy, sulfur-yellow haze that hangs over the entire sky. Venus is a broken rockscape that violently rejects all visitors. The extreme heat and crushing weight are only the visible layer of its hostility. In the early 1990s, NASA's Magellan spacecraft bypassed the clouds by using a massive synthetic aperture radar dish to map the world from orbit. By firing radio waves straight through the toxic layers, Magellan hit solid ground, measuring reflections to map surface textures. Reconstructing these into a 3D wireframe revealed extreme geology, endless lava oceans, flat domes, and massive shield volcanoes. When researchers counted the impact craters across these plains, they found a discrepancy. Unlike the Moon or Mars, which are scarred by billions of years of collisions, the surface of Venus is remarkably smooth. On most planets, craters accumulate like a geological timeline, but on Venus, the count is so low, it suggests the entire surface was reset only 300 to 500 million years ago. To erase that much history, the planet underwent a cataclysmic resurfacing event, where the crust melted away and fresh magma paved over its global history. Venus is a world shaped by global geological chaos, but the activity that reshaped this planet may not be a thing of the past. In 2020, NASA's Parker Solar Probe flew past Venus while on its way to the Sun. The mission team pointed its wide-field camera at the night side of the planet to see if it could glimpse the terrain. The probe captured a faint, ghostly glow, radiating directly from the rocks. This wasn't reflected sunlight, but thermal emission, the signature of intense heat bleeding out from the geology itself. This thermal signature led scientists to re-examine old Magellan radar scans using modern processing. They compared images of the same volcanic vents, such as those at Mont Mons, taken only 8 months apart. The before and after snapshots showed physical changes. Volcanic vent walls had collapsed, pressure domes had deflated, and fresh lava had spilled out across the plains. These shifts indicate the deep interior of Venus never fully cooled. The mantle is still churning and pressurizing, forcing magma to the surface today. The assumption that Venus is a dead world was wrong. Beneath the clouds, the planet is actively erupting. These eruptions are a primary driver of the planet's environment. Magma bleeding out from the crust constantly alters the chemistry of the atmosphere, feeding the very clouds that keep the surface hidden. Future missions like Veritas and Envision are being built to map these live eruptions in real time, using high-resolution radar to peer through the gas and watch the world burn. Venus is Earth's twin in size and composition, and it likely once harbored liquid oceans. Its current state is the result of a catastrophic runaway greenhouse effect that turned a habitable world into a furnace. Studying these eruptions is a look at the physical limits of a planet nearly identical to our own. It provides a blueprint for how a world with oceans and moderate temperatures can slide into a permanent atmospheric nightmare. To survive the cosmos, we have to understand its most extreme environments. Subscribe to explore more of the universe's most hostile realities.